Yeah. Uh, if you look at, we'll have a bigger picture here. Before starting to the concept, let us have a bigger picture. Okay. And this bigger picture is like how we are reacting, like as per the concepts, how we are reacting to the programs. Okay. So if you look at a general program which is written into a C language, you'll find that a program will have certain sections, out of which, like say, first section goes dependencies declaration. Okay. So this section is, I'll say, dependency declaration. Okay. Dependencies. So all dependencies goes here. So like whatever libraries that you are in need, that we have included here. Then we certainly thought of having some global declaration. Then we can have a main program. Now if you look at main program, it has certain sections in it, right? Say for example, first particular section is, this section goes for definition of variables. Okay, definition of variables. Then this section goes uh, goes for handling some input output, and then this section you can specifically write for process section. Okay, then this particular end up section, you can say this uh, this okay, this end up section is like, say, this fourth section is, I can go for visualization or outputs. Okay. Now, if you look at this process section onto a bigger scale, you will see that this process section may include, like say, call of functions, different functions, right? Or some processing operation. Either I can have a call to a function, or I'll have a processing operations right here. Okay. So this is important. So if it is a call to a function, then ultimately you think of a block, right? So this is the block, this is the block, right? This is the block. Like it is like block-wise call, right? So it means that they are being called, and they get processed and again returned back, right? They got called, they get processed, right, from top to the end, and again it goes. Okay, if you look at this particular picture again in a broader sense, you'll find that this again carries the same sort of concept. Okay, what it is exactly, it has certain data. Either this data can be taken from the main or the local data you have, local data, or you can have, say, some global data if addresses are being passed. Then kind of processing visualization, right? And this section, fourth section will be uh, fourth section will be returns. Okay, and this processing visualization may leads like calling to another function, and likewise. So means what, if you look at this picture will be something like a pay data, again it will call some data, again you have some, like this kind of representation. Okay, so this is the series kind of representations you have. Okay, so this is, and all your functions are going to be in the fourth section. So this is for dependencies is the first section. Section B is your global declaration. Section C is, this particular section C is your main, which is default entry point of the execution. And section D, which you are going to have, this section D are nothing but all functions. Okay, it has got all functions. So if you look at these variables now, if you look at this global representation, global declaration, so what this global declaration will have, so global declaration will have some information like prototypic definitions. You have prototypic definitions. You have some global variables. Now, if you look at these global variables, are they are something which can be directly accessed in any of the functions. Okay, so it is global variables kind of thing. Okay, so they are indefinite is written here, and this prototype will help like again to determine the functions. Okay, so your function goes here. All your functions will go this particular section. So this is function one. If you look at this is one function. Okay, then you can have another function. So you have got such series of functions written here. Okay, one after another sequentially. So I don't have that space to or visualize it, but it is a function one. You can have function two. You can have function three. You can have function four. Right. So many so forth functions you can have it here. So like this. Okay, and as what we have discussed in case of demand paging, that they're being divided into pages, right? Say for example, they are being divided into pages. Say for example, this particular section is going to be page one. Say for example, okay, this particular section is okay. So this is page one. Then this is going to be this particular main is going to be, say for example, this is going to be, so this is page one. So this is page one. Then this is going to be page two. Then this is page three. Then this is page four. Then this is page five, page six. Okay, and they are uh, uh, entered, this particular information gets entered into page map tables, right? So and from this particular page map table they are going to form memory block table, and then they have been loaded into primary memory. So if you look at here, so all your data and code are data and code are strongly associated here. Right? Data and codes are strongly associated here, and when you are trying to divide this into pages, we are not actually taking care of the data and the code, because right now the data and code are bounded together. Okay, so now the idea is like, okay, this is like say for example, if you define certain data into a global memory, right, global declaration, and you need it, you need that particular information into page four, right? So what we need page one also, and page four also, right? So like means what, it may be a case that it may leads to dependencies, right? So you need that page also and this page also. So in case of having this, uh, the basic idea is like, instead of having these pages, let us try to have a segments. Okay, so instead of dividing this, instead of dividing this into pages kind of mechanism, let's have the new idea is let us try to have everything in the form of segments. Right, so let us have everything in the form of segments. Okay, everything in the form of segments. Okay, so which means that the codes are different, datas are different. If you need a stacks, then the stacks are different, and accordingly you can have a different segments altogether here for all your work, right? So in short, what you can do is what you can do is that you can prepare different segments, like for your code. So code segment may contains information about all your functions, right? They're integrated onto one particular segment, right? And then if you look at datas are particularly like all your uh, arrays will go here, okay? Then all your, if you have created lists, right? So it will go here, all your datas and lists go here. As far as this stacks, these are particularly used for all your instructions, right, which you are going to get executes. Okay, so the new idea is trying to have a segment. So like if you have a segment, then this segment carries certain property, because you never know like how long is my data, how long is my array, how long my list, right? So these segments are not of fixed size, right? They are not of fixed size, right? This is this kind of like, okay, you have, say for example, you have got say a growable segment. These segments are growable segments. Why it is growable segment? Because you never know like how small the segment is going to be, or how small the data is going to be, and how big is the code is likewise. So these are the growable segmentation segments. So the new idea is, instead of having the data into a place of which is of a fixed size, let us try to have the data. Let us try to have a grouping of segments together, and this grouping is a logical information, logical grouping of information based on the type. So the segments are, but it is logical grouping of information, logical grouping of information based on type. This is important, that we have segments based on logical grouping of information based on type. Now, but type means whether it is a data or it is code kind of thing, right? So based on that, we can go ahead. Okay, so the picture is like, so the picture is going to be like, all, say if all global declaration and data, so we will have one picture. Okay, so which means that, okay, so you can have one segment here, which is like uh, segment A. This segment is dedicated for main. So this is main segment. Okay. Now, now you have another segment called this one more segment. Say segment B. This segment B is for your subroutines. Okay, this is for subroutines. So this segment B contains all subroutines. So in short, like this is going to be one subroutine. This is another subroutine, right? This is third subroutine. So you can have four subroutine and likewise. Okay, one particular segment, again, we will say segment C. Segment C is for, say, for example, all your datas. Okay, data. So segment is either array or you can have list. Okay, so this is what is first array you have, second array you have, or you can have this kind of list information, right? So it is like this. So uh, you have got this particular data, and you have one more segment like this. Say for example, if needs like segment segment D. Okay, so this like work area, So means what, at the execution, if you need something, you can place it out onto a area kind of thing. So means what, if you have different segments together, rather the pages, logical grouping of the information. And if we make a logical grouping of information, it is always better. And we have marked the place for the data, like okay, all functions should go into segment B, all arrays whatever required, right, then those arrays will go on to segment C. All your whatever your entry point of execution, that is main, that should go into segment A. So where we got a clear demarcation of the process. So which simplifies the management, so because we know that what goes where. Okay, so this is the basic case. Okay, so this like, if you start managing this kind of information, you are almost looking for segmented memory management scheme. So when we are involved in management of this, then it is called as segmented memory management scheme. Okay, this segmented management scheme. So the basic idea behind segmented memory management scheme is to make a logical grouping of information based on their types. And once that logical grouping of information is being done, then that logical group of information is called as a segment, and those segments are being managed. Okay, so in short, you have seen the segments like code. There are type of segment, then data segment, stack, and all. Okay, so the segmented management scheme is designed for this particular purpose. Now, if you look as a environment, all address space references requires two components particularly. Those two components are nothing but as part of this hardware, you can see you need two components specifically. Two components. This two components for all your address space. So the first component is a segment specifier, and second component is the location within segment. Okay, since we understand this particular data, that segment specifier from where the segments are being started. So this is say this is starting address and this is the ending address of the segment. Okay, and the location within the segment. Say for example, this function A, this is function B, this is C, this is function D. Okay, segment specifier says that okay, this particular segment starts with say for example X and it ends with X dash. So size, you directly compute X dash minus X, the size of the segment. But now into this particular size, where is my function A? So you need a location specifier, so which is telling me that okay, within this particular space at this particular location my first segment exists. So this is really very important. So as far as whenever you are looking